So I'm Simon McCormack. I'm part of the product management team for Plexxi, and I'm the chief demo guy, apparently. Chief live demo guy as well. Nothing like doing a live demo in front of a live studio audience. See my screen. Okay, so we actually have a lot of demos part of this, so I'm going to try and go relatively quickly, but I'll probably go through it in a fair amount of detail. Feel free to ask questions and jump in. The key concepts, I think, that I'm trying to portray through the demos is Plexxi, obviously, we've got a range of switches. The switches, you connect them together. The way you connect them in Plexxi world in networking is very different from most of the traditional vendors. Not really going to go into that in this session. We've done other sessions at Network Field Day where we did go into what we call the physical topologies that we can produce. You won't hear us talk about leafs and spines in this. That's probably the last time we'll say it. We form fairly intuitive, fully meshed type environments. You'll see it a little bit, but I'm not going to talk too much about that. I'm focused today on what in typical networking we refer to as the logical topologies. And with our software, we're basically able to build dynamic logical topologies, what we're calling Affinity topologies. And you'll see that through this event-based automation, we're going to build dynamic logical topologies. The logical network topology really refers to L2, L3 type networking connectivity that traditional switches and routers will form. So traditional network equipment, you'll plug it in, it'll form logical topologies. We've been doing this for a long time. We have a lot of abilities through our automations to influence and create these logical topologies, which essentially refer to the multi-purpose network that Matt was talking about. And a couple of themes from that is how do you, through the demos, is how do you visualize these logical topologies? So we've progressed a lot in how we visualize it, and we've got a lot more thoughts. So Erica's going to come on and show the more advanced, Eric and Jason, actually more advanced ways to visualize the topologies, but also the way we interact with it is fairly unique. I've got my GUI up, but I'm going to show you more than just the GUI when we actually interface. And that's the theme of the demos. The demos itself, very quickly, our prime demo that I'm going to talk about when I go to the whiteboard in a moment is our pod expansion demo, which is a VMware-centric demo. So if you're familiar with VMware vCenter, then a lot of it will be familiar. We're going to do that, and I'm going to talk about that in a few moments. We're going to then do a little bit about Nutanix, converged infrastructure demo. And then Eric's going to do his visualization piece, and then Kevin is going to come along and do Hortonworks, Ambari, Hadoop type environment, and build little logical topologies for that as well. So it's all kind of the same themes. Now, the physical infrastructure setup we have here that I'm showing on the board, pod A, pod B. Essentially, our pod A's got a couple of Plexxi switches, and we've just set them back to factory defaults. So there's no networking layer up. They're up and they're running. There is, however, both vCenter and Plexxi software running. If I jump to this tab, we'll see here's my vCenter. So I've deployed a bunch of VMs on Fred and Barney. And I'm communicating with them through out-of-band management. So I've given myself that luxury that I've at least got out-of-band management up and running so I can talk to all of the infrastructure. But the network fabric layer is basically down right now. In fact, Plexxi Control, which is this guy, does not even know about the switches yet. So it's in that kind of state. If I go to my, also as I mentioned, we have, Kevin's going to show the Hortonworks later, but if I go to the application layer for Hortonworks, Ambari, basically it's telling me it can't talk to any of the nodes because obviously network's down at this point. This one says he's up. Well, he happens to be sitting on the same ESX server as the manager. So essentially the whole thing is down. Makes sense. Now to bring it up in a traditional networking sense, you've got a lot of buttons to press, a lot of configuration to do. You've got to figure out VLANs, connectivity, enable ports. So we're going to do all that automatically. First step in a Plexxi environment. So I've got a couple of Plexxi switches deployed. They're at defaults. I have to bootstrap them to tell them about Plexxi software. So I've got to do one command. Typically, I've got to log into one switch. I run this one command. The Plexxi fabric learns that communication. They share it between them. And they connect to Plexxi Control, and the fabric will come up. We've done this demo a lot. So actually, people didn't like me when I typed the command when I used to do it. So I actually automated the command. So I'm going to run my automation, which runs my command.
When he says people, he means rich.
Yeah, so these guys. It's like, do you have to type that command? So, okay, I'll automate it. No problem. So I've got a little Python script. Of course, I'm not connected to it because it's disconnected me. Oh, there it is. No, it is there. Got a little Python script. A little bit of delay. Thank you. Start demo, I called it. The start demo is going to log into one of my switches and configure it and tell it to start talking. So I'll just wait to make sure it's actually doing it. Yep, so it did it. So basically what that's done is this switch, probably this one, I logged in and I told him where the controller is. It's Plexxi control. He shared it with the other switch in the fabric. If there was more, they'd all share it and they form a fabric, connect to it. Within a few moments, we'll see it starting to come up in our Plexxi control software. While that's happening, first one's come in already, so that's pretty good. What's our Plexxi control software? This is just running on a VM in VMware, the Tomcat web server type application. It is front-ended by a web GUI, as you can see. The web GUI itself talks 100% REST APIs to the Plexxi control core. So you as a user, if you want to interface with it, you can also do 100% REST APIs to communicate with it. So everything you see in this is all through REST APIs. So it's all completely automatable, which is why in a little while we'll do more automations. So I've discovered a couple of switches and I can look at some of these tabs now to show me, okay, I found a couple of switches. They have some alerts. Why do they have alerts? Let's quickly clear that. Those alerts telling me because I reset it earlier. So it just remembers the fact that I reset it to factory default and rebooted it. So I'll ignore them. There are not really any alerts of any relevance. So that's it. 2 switches connected together, 1 big cable. Not that exciting yet. It's going to get more interesting when I expand it and make them 4. We have links between them, many links. There's so many links that they're basically written over each other. But that, like I say, that gets more interesting as we do it. Now, go back to Ambari. Still not happy. Nope, networking's not up yet. So if I go to the switches, let's have a look at the configuration. It's classic network configuration. All the ports are down, right? Typical way they're deployed. So someone's got to enable the ports. Okay, which port is my vCenter connected to? Oh, no, which port is my ESX server connected to? I don't know either. So that's the first thing you do. And once I figure out the port, then I can then configure the VLAN. That's the classic thing. And the typical networking, SSH to each switch and do the same thing. Fat finger half the commands, get it all wrong, it doesn't work, everyone's unhappy. So we're going to automate it so that I don't have to do these silly commands. That's where Plexxi Connect comes in. So Plexxi Connect is another software piece running on another VM. Why is it separate from control? Control is the master of Plexxi. Connect is how we interface with the third-party products that are out there. Classic network, I've been in networking for a while. Classic networking, where I started in networking, was network switches just pass packets. We actually don't care what is in the packets. There's a payload in there. We don't care. We just pass them based on MAC IP data. Send it on its way. Doesn't matter what they are. We like to think we've changed that model with Plexxi. We do care about what the packets are. They're packets from hyperconverged storage vendors. They're packets from VMotions. They have different precedents. With a Plexxi Connect integration, we can build the logic in here to actually do a better job of pushing the packets around and building our logical topologies based on what the application is. So I'm going to show that here with an example for VMotion a little bit later on. First thing I'm going to do is configure it. So I've actually pre-configured some stuff. You'll see in this one I've actually got a bunch of Connect packs in this. I'm focused on vSphere and Plexxi in this particular demo. So I'm going to do that. I've actually got a little tab for them, configured Plexxi control. So I told it about Plexxi control, gave it the credentials, and I told it about vSphere as well. So that's my vSphere instance. Right now it's not working because I broke the password on Plexxi control so that it didn't configure it before I was ready. So if I go into actions, validate, it'll say I can't talk to it, which is why it's not. This is one of my favorite features, actually. If I edit it, fix the password, if I can type it right. Again, I don't know, did I do it right? This is my great favorite feature, validate. Before I save it, I can check it, is it actually right? Yes, it's validated and correct. Update it. So now what's going to happen is I've told Plexxi Connect about both vCenter and Plexxi Control. Plexxi Connect has gone to vCenter through vCenter APIs. There's a little separate module for that. Pulled all the information about the hosts and the VMs on vCenter.
So how did it connect to vCenter if the network's not configured yet?
Out-of-band management.
Oh, okay.
So common practice for medium to large data centers, you probably want out-of-band management.
So your vCenter is actually in a separate pod from...
1 gig network. It's a good place to put all your 1 gig stuff. There's a lot of people who've got the 1 gig, so you can do it all in band as well. But obviously, if you're in band, you've got to bring something up before you can.
Anyway, you've got a separate management pod with vCenter and a separate switching fabric that's...
Exactly.
Okay.
It's not trickery. It's just, for us, that's the standard practice our customers typically do. If they go in large data center without out-of-band management, you know, they're putting themselves in a bit of a pickle if things start to go so well. You can't even access the devices you're trying to work through. So that's a standard thing. And you can just do that typically with a 1 gig type network. So people that are migrating from 1 gig to 10 gig, they've got a lot of 1 gig equipment hanging around. So it's a good way to do it.
It's still a little strange to hear 1 gig is
so
old, slow, crappy. I think I still have some yellow thick Ethernet line around.
Yeah, exactly. So you've got the stuff you can do your out-of-band management as well. Just for
it's hard to get 10 meg connected to vCenter.
So this is all the stuff in vCenter. There's 3 hosts, Fred, Barney, and Betty. There's a 4th one, Wilma, but we'll get to that later. vCenter doesn't know about Wilma yet. What Plexxi Connect has done is it gone to vCenter, it's gathered all the networking information from them. Virtual distributed vSwitches, port groups, the VMs, the host connectivity, the IP addresses, MAC addresses, VLANs, everything. Plexxi Connect has pulled all that from vCenter. And it had it sitting in its cache actually waiting. Now we've connected it to Plexxi Connect, Plexxi Control. There's business logic we put in to basically populate Plexxi Control with all that vCenter data. Why do you care about that? So when packets actually arrive on the network, the information on those packets is sent from the switches to Plexxi Control. We now have data from vCenter that says what these things are. We see live packets from on the wire. Tie the two together, we can now build a little picture that tells you everything is. That's just almost like a side effect of what we're doing. But if I go to my network view and I see my switches, I have vhosts connected to it. So this icon, so it's clear what it is, this icon vhosts 1 tells me there's a stack of vhosts. Normally there'd be more than 1 in most data centers. I only have 1 in this demo, so it's a stack of 1. I can click on it and I can look inside it and I see that actually it's Barney. That's where Barney is. So I know live now where he is. Now this is validated information. The switches has actually seen frames from him from his source MAC. So he knows which port he's seen them on. So from a troubleshooting, validating what's going on, this is actually kind of a powerful tool in itself. That's not really the purpose of this. The purpose of this is to build a logical multi-purpose network, which gets more interesting. How is Ambari doing? Ambari, so one of the hosts has come up. So I didn't do anything right. One of the hosts come up. So host 5 now is talking to host 6. 7 and 8 are not talking because they're in the other pod. So we'll get to them. That's a good little check for me to know, is networking up? Let's see what happened if I go back to here, go to configuration, look at the properties, edit, and you'll see the ports came up. So Plexxi Connect saw the switch and enabled the ports. So actually that's an interesting feature because we've got a DevOps version of Connect coming out. Plexxi Connect 2.0 VMware does not have that feature. I added that a couple of days ago myself. It was 8 lines of Python to enable all the ports on a switch. So I decided for myself, I like to see all my ports come up. I don't want to configure them manually. It just shows the power and simplicity of the way we can do that. If we have time, or maybe during lunch, I can show anybody, if they want to do how I created that little action to enable the ports inside vCenter. It's pretty cool and very, very easy to use. So that just enabled ports, fine. But there's VLANs. So if I go into vCenter and I look at my port group configurations for a bunch of VMs, you'll see there's VLANs on them. Well, you can probably trust me. Trust me, there's VLANs. So what Plexxi Connect did was learn those VLANs from vCenter. And then by understanding where the hosts are from the data that it's seen on the wire, actually one of the key things we've learned is we have LLDP turned on the distributed vSwitches. And Matt talked about we have a little Trello operation for it. I can actually show that. I have that thing that we could move to in a little while. So if you can get, the distributed vSwitch allows you to turn on LLDP, link layer discovery protocol. It just spits out a message saying, here I am, this is my Fred and Barney, they're basically saying, here I am. So we know on all of its ports, so we know where they are just from that. And we use that information. If that's not turned on, there's other ways to learn where they are. But that's a simple method. So we now know which physical port they're on, because that's an unpacked frame. And now we can configure the VLAN on the port. So if I go to my VLAN configurations now, VLAN groups is how we configure it. I'll see them both. And we've configured 100, 234, and 567. 567 is Hortonworks. That's what I configured for that port group. 100 is my VMotion network. So that tells me everything's up. It's all talking. So if I did a VMotion now, it would work. Again, you know how difficult it is to get VMotion working sometimes on a network? We've done it without actually configuring anything.
Fine, I get Twitter up.
And there's more than that when we get to actually show it. So, yes, this is interesting. This is up. Everything's nice. Let's expand the pods because it gets much more interesting when we do that. Now, for this, we have a DevOps automation to expand the pod, but there's a physical cable I need to move. So I'm actually going to ping our DevOps guy who's going to make the physical cable move. We tried to automate everything, but this bit we found actually needs a, so I'm going to just tell them.
But this is where you need a Lego robot that's driven by your
robot will be good, but we're using a human in this case.
So that's a bio robot.
Let's see if he responds. You'll see messages in this view. This is obviously I was doing it earlier to check that it still works on it. Good. He was meant to respond like a robot, but I guess he failed in the end. So again, the theme I was talking about is how you interact with it. So traditional networking, you interact with network equipment by SSHing to the switches. You can do that in Plexxi if you really want to. If you've got 100 switches, you can SSH to each one individually and configure them all individually. We prefer the model where Plexxi Control does configurations. So in this case, just so you can understand how I configured those switches, I created that little Plexxi Connect module that said enable the ports. It was 8 lines of Python. It told Plexxi Control configure these ports. Plexxi Control then went to each switch and configured it. So as a user, I don't have to go to each switch. Plexxi Control is the master of those configurations. Why has it been crossed? Oh, that's his humor. If I go back to it and I see the dashboard, then stuff's starting to happen, right? Oh, I've already got 4 switches. He was quicker than I was expecting. Simple view is we go to visualize and we've gone from 2 to 4. So basically those 2 switches, he basically just connected. The connection was here, he stretched one here and stretched one here. We formed a circle, is what I like to call it, of connectivity. It's like basically a fabric. It's a redundant connectivity because you could basically cut any cable in that infrastructure and it would continue to work. The switches, when the new switches came on, they learned from the other switches the location of the controller, so they didn't have to configure that piece. Now Plexxi Connect,
Is there any security ramifications around this? Because that's obviously a virtualization network that's bringing up ports. But if I have now a physical infrastructure, maybe for a big data or a distributed Cassandra database or something like that, which also has its own VLANs, somebody's just going to stick a VLAN in vCenter, that's going to pop up on the network. That VLAN may already exist or be used elsewhere. I'm thinking a absolutely clueless networking vSphere administrator can just go and add VLANs and go crazy.
Well, the default is it's off. Okay. By default, if you've got a very strict security policy, have it off and you can configure it all manually. Get the security guy to do it because he's stopping you from doing it automatically.
Or the network person can go and then create I do like that you create the network in one place, be it vCenter or Plexxi, and
but in any real environment, there's going to be business logic that, and part of Plexxi Connect is letting you automate that. So, for example, you could actually stick the request for this VLAN into Trello, into a Trello queue that says, please approve this, right? And until somebody physically drags it out of that queue, which triggers the automation to continue, right? Those kind of things can be very much customized.
Let's show it.
So there is a sort of workflow security.
As an example, we'll show you that example here. So instead of just making it all happen, I can have it so it's a. Okay. Let me go to my Trello board.
It's going off script. This is dangerous.
Well, it's good to talk about it when we're here. So this is my Trello board, Plexxi Connect Trello board. We've plumbed into it. We've only plumbed in this example one workflow, but you could plumb in everything. That enable ports that I did, you could plumb that into this if you want. It's actually relatively simple to plumb the things to do together with Plexxi Connect. Nothing happening yet. So the interface that we built into this is actually through Slack. It doesn't have to be through Slack, but we wanted to interface it through Slack So if you're familiar with Slack, we use it for all our communication stuff. Wires have been crossed. So I have a Plexxi Connect Trello module Plexxi Connect Slack module listening for Slack messages. When it receives that message, it's basically publishing it on the message bus saying, here's a Slack message. I have a trigger inside my Plexxi Connect, my Plexxi part, that is listening for this message verified DVS. Once it sees that message verified DVS, it's going to create a card inside Trello that is a config request. In this automation, it's actually automatically going to move it to the next stage, but you could have it so that it needs someone to verify it. So you could just have a human says, oh, you've got a card, needs verify. You can look at what the work order is and move it to the next stage, and then the automation will work.
And that automation can be in any tool.
Yes.
I mean, obviously,
Yeah.
Trello and Slack are the cool new ones, but
Ticketing
the most
system,
horrific tool
right.
in use, like Remedy or something, would have an approval.
The beauty of this architecture, and again, we could spend an hour on the Connect architecture, it's all modularized. So there's a Trello piece, there's a Plexxi piece, there's a Slack piece. You can replace the Trello piece with anything, and you don't have to change all of the Slack and Plexxi pieces. So let's do verified DVS. So the Connect module is going to listen to that message and then respond to me.
That's a real robot.
So this is a real robot. Verify, he's acknowledged that he's seen the message. Now he's going to decide what he's going to do something. He's going to basically submit the config, and I've got to get back to the screen before it goes off. Yeah, so you've seen verified DVS config has come in here. So this could be stopped, not go anywhere. It's actually going to automatically move the card just to make the workflow work. So it's moved the card, it's in progress. It's now logged into vCenter. It's actually checking the LLDP setting on vCenter. If I changed it earlier, then it would have actually done something, but it's actually going to not do anything. But you see, that's how we can build in. So for the VLAN configuration, you could have exactly this into the VLAN configuration. So no VLAN is configured until someone manually approves it. Let's go back to my, what else do we want to see here? So, you can assume then we've configured more ports. We've configured more VLANs. I see update VLAN. We enabled the ports on the new switches. If I go to my network view now, it looks a bit messy, but actually this allows you to draw. It's kind of a little drawing tool, this one. So I can build it, make it look the way I like. I like a flat network. There we go. Better. So I've discovered 2 more hosts, and I'm up to 4 switches now. Much more interesting. And on it goes. We did something else on this as well. So you noticed before there was only 3. There are actually, so it's showing only 3 ESX servers. This is part of the demo we've actually built it into. I'm expanding the pod. I'm including this new pod, but vCenter doesn't know about this ESX server. So we actually built a little Connect module to say add ESX server. That was, I think that was 15 lines of Python to do that one. So it's a simple operation like that, incredibly simple once you've got the infrastructure in place. So 15 lines of that, it tells vCenter about Wilma, which basically gets added to vCenter. If I refresh this screen, we should see that it's been added. So you can really automate, and there's Wilma's turned up. And Wilma has Hortonworks machines on it as well. So there's Hortonworks 7 is now turned up. If we go back to Ambari again, they're all green now. So I've got Ambari Hortonworks stuff up and running and configured without touching anything. Even a new ESX server's come along with it connected. So don't worry about the alerts. It's just, obviously, all of these tools, they're not really happy when you break their connectivity for long, but it's now recovered. It's just leaving the alerts around from before that it wasn't connected. Okay, let's move on to more things. So we've got all our networking up and everything's like that. Now I want to do a VMotion. So we have logic built into Plexxi Connect, event automation to sense the VMotion. Now, typical VMotion is just going to go on somewhere on your fabric. It could consume a lot of traffic on the fabric. It could go on a fabric path that is congested. That's traditional networking. You don't really know where it's going to go. It could go anywhere. So sometimes people, they don't like doing VMotions on the networks because they see it's a lot of traffic. It doesn't always work. Sometimes they build separate networks just for VMotion, which is a little bit of a expensive proposition to be doing that for VMotion. So what we've done is here, we've actually built the logic into Plexxi Connect to tell control about the VMotion, and for control, we'll basically build a logical topology dynamically for the VMotion. And it'll look for a path that's not being used. To prove this out, I'm actually going to congest a path. So I'm going to fill the fabric up with traffic, and I'm going to turn off Plexxi Connect, and I'm going to try and VMotion across it, and we'll see it fail. I'll turn Plexxi Connect back on, and then we'll see it do its magic. So 2 quick things I've got to do. A, I've got to check my traffic generator is working, which of course it isn't, because I can see it's complaining. Let's log in, and there was 18 steps I needed to do before I started this. This was one of the 18 steps. Of course, I forgot this 18th step. That, again, the Spirent is pushing traffic across, but obviously I disconnected everything, so it then decided to be disconnected and not work. So now it's going to connect again in a few moments.
We're using Spirent to generate background traffic on the network because we actually have, those switches each have 240 gig between them. There's a lot of fabric capacity. We can't generate that much load, so what we do is we bit blast it to generate enough congestion that we can see what the effects would be.
And I've got to turn it on. So traffic will start to flow. Don't worry about the errors. So traffic, so I'm pushing, up to 60 gig. Okay, so that's good. That's going to be there now. There's one more thing I have to do. So Plexxi, in this fabric, this is our network capacity now, because we've expanded it for 4. There's a ton of paths. There's more paths than the 60 gig I have, so I have to pare it down. So I'm going to build a little logical topology which only uses a portion of this fabric. So I'm not going to go into this too much detail, because I'm just going to assume I've just reduced the fabric capacity. We could talk about it offline, what those settings are. It only takes a couple of seconds to do it. So it's done it already, and now I can look at this particular, the PSAT topology is one of my logical topologies. And you can see it's basically, there's only a little bit of fabric capacity. If I turn on stats in a little while, it'll show me that actually it's congested. So it starts off, everything's good. Now the traffic statistics are coming in and telling us about it.
So in software, he's told the fabric you only have these paths to use. So it's only a couple of 10 gig paths. So even with 60 gig of traffic generation, now he can congest it.
Yeah. So why would you only build a network with only a portion of your fabric? Because I'm basically saying for my traditional residual type traffic, I'm going to give you this much traffic. I'm now going to build VMotion and give you this much traffic. I'm then going to build the Nutanix environment, and I'm going to give you this much traffic. So I'm going to give each of them a little bit more traffic. Go to my Spirent. Spirent seems to be talking. I assume there's a lot of traffic there. Temperamental in the demos. 75 to 77. Yeah, it was starting to color. It was premature. I assume it's already loads of traffic there. So what we've got to do is break Plexxi Connect very quickly. Control, edit the password, type in a random thing, validate that it's broken. This will stop Plexxi Connect intercepting and doing something, so Plexxi Connect will not now interfere. I can do a quick test VM3 is a good one. I'm going to migrate him. Just let me jump through the options. I'm just taking all the defaults. He is on. Where is he on? Yeah, I don't even remember, do I? That's smart. I've noticed vCenter. If vCenter's on, if it was on Fred, vCenter will allow me to vMotion it to Fred, and we'll accept it and do it, even though it doesn't go anywhere. So you have to know where it is. It's on Barney, so I'm going to migrate it to Fred. So that's good. Migrate, change both storage. In this particular environment, we don't have shared storage. It's individual storages. The next demo will do Nutanix shared storage. We're just showing the different options. And so one of the questions often is, for this, we have a mix of standard and distributed virtual switches as well. We both support both of those. And we do finish, and then we'll look at the tasks. So we're just doing a standard vMotion, but it's congested. So what's it going to do? Shouldn't be very happy, that's all I think. I'm going to scroll down. So we've learned by doing this a lot. 29% means it's trying to talk to the network. So that network is full. It's just like banging its head against it. Nothing's happened. It doesn't take that long to fail. It'll take probably less than 30 seconds, and it'll say, I can't talk to it. I give up.
And again, for clarification, it's not that the network's not there, it's just that you've crammed it full.
I crammed it full intentionally to break it,
Yeah.
you know. What I do is I like to say things, when they're doing live demos, I like to say things are breaking, so when they work, it's good. So when it fails to work, this time intending to break it. Of course, if it actually worked, then it would be kind of annoying, I guess. But it did fail, right? So
And it doesn't have to, in a normal network, it doesn't have to necessarily be a fully congested network. You might just, that VMotion just might get placed on a link that's congested. Right? You might have, again, capacity.
It may be big enough that it congests it itself, and part of it gets through, and it becomes very frustrating. So I'll fix the password, verify that it's fixed. So Plexxi Connect is back in play. Oop. Yep, I know it's failed. Go back to my test VM3. Go back to migrate. Oops, actions, migrate. And we're going. So it tells me, yeah, it did know that there was failed to receive. I don't know what the message is kind of different every time. That's a new one. But obviously, it couldn't talk to the network because it's too congested. And we can simply just tell it try it again. In fact, if you just say finish, it'll try again.
So with Plexxi Connect not running, you don't have actually any visibility into this issue happening.
But with Plexxi Connect running now, if I show you the troll, we've already detected it, and we've already basically created what we call an affinity. It's basically an abstract view of this connection, and that affinity rule that I'll show you in a moment says isolate this VMotion traffic, and then it put it on a path. If I go back to here, see it's already at 32%, so it's already we know it's talking to the network then. Let me go and show you what we did. We created this thing called an affinity. Affinity in this case is just a simple endpoint affinity. The business logic in Connect figured out the endpoints. The endpoints for a VMotion are the VM kernel adapters in vCenter. And they have a tag saying I'm VMotion. So we know deterministically who's doing the VMotion. The user didn't have to tell me anything, right? That's the key thing here is a lot of this theme is which port are my hosts on, what VLANs on there, what adapters they're using. The user didn't need to know any of it. We figured it all out through the APIs. So we built this funny little model. You'll see it's actually, you can see it's figured out Barney and Fred's VM kernel adapter that's got VMotion enabled on it. VMK1 happens to be the one. And we built this rule that's indicated by this line that says isolate it. So there's other options we can do, and Kevin will show you a lot more different ways that we can build traffic profiles. Key thing about Plexxi is if you want to build a Plexxi network, you can build a Plexxi network and do none of this. And standard networking will build a network and traffic will pass. You don't have to do any of this to build a Plexxi network. But this allows you to do the smart things. So this is what this is about. I don't want you to think you have to do this before you can pass packets. This just allows you to build a better network. So this example, I just said isolate it, the traffic passed, go back to vCenter, and it's still working, but it's getting there. Actually, I tend to find vCenters are usually a little bit behind, but it's still going. But you can see basically it's going to succeed, and the VMotion is.
That orange circle is a relationship. It's what we call an affinity. So the things that are connected to it are related to each other. They have an affinity to each other. This one happens to be one that we created. Temporarily, so it's going to go away after.
But you also still throttle to 1 gig connection for that VMotion.
The VMotion is configured to one of the 10 gig fabric paths.
Okay, so that because you had set it manually to 1 gig just to flood it, has that 1 gig now dynamically scaled?
That was just an input to our algorithm to build the topology. So the input says I'm going to average about 1 gig, so build me a fabric path for it. And of course, it built the minimum it could do is a 10 gig path.
Okay, so it's done.
So it actually built a 10 gig path for me. That's why, to that input to that, it's a thing we call the traffic matrix that lets you build the residual traffic profile with very little input. It's basically just saying I'm not going to expect a lot of traffic, and so it builds a small.
And then this is also physically, you may have multiple vMotions going on, and physically this is a direct connection from one switch to another switch, always a direct connection, even though it may be flowing around the ring. From a bandwidth point of view, you're not switching as you're going.
From a physical point of view, it looks like you've got a dedicated Ethernet wire. It's not a trick. It is passed through our fabric. It is actually, you could look down the light and you would see the other end.
But as it's a mesh, it's literally a point-to-point connection.
We've used one of the point-to-point connections from that mesh for this, and we looked for one that was free, that nobody else had used. Our fitting computation from control is the master of this, so it knows who's talking where. It's the complete control over it, and it then tells the switches, put this traffic there, and no other traffic then will go on that path.
And then if that one particular link between two switches is flooded for whatever example, you can use the links from the other switches, but switching them as well.
Yes.
Okay. So you got lots of bandwidth.
There's also lots of direct paths. So if that one is not free, I might have another direct path. If I don't have a direct path, yes, I can do
Okay.
Yeah, and the examples, so everyone's clear about that. So I've got traffic going this way. If these were all congested, the logical topology could build a path from here to here and dedicate that. So if there's less traffic, say, between these two guys, that's only partially used, these two guys could actually use this for their communication. So that's covered in other sessions how we do that a lot, but it's basically we build this mesh topology and allow the software to build a variety of different topologies. Hopefully it's finished. Yes, so it's completed and the VM has got VMotion. So that's, I think that's it mostly for this pod expansion demo. If there's any other questions while we're doing this, I'm going to move quickly on to Nutanix and talk a bit about that. So this, as Matt said, we basically GA'd this yesterday, right?
Sure.
So we actually shipped this. We had a previous version, but this is the latest version with our Connect 2.0, which has got all this advanced capabilities. One other thing we have, a vSphere plugin. That was the only other thing. So in terms of how you visualize things, actually, I didn't really cover this, but I was thinking about it, is that the way we think about Plexxi Control, you see it's got a GUI, and you can interface with this GUI, but our vision of Plexxi Control is that actually we want it to be kind of transparent. We don't really want users going to Plexxi Control for day-to-day operations. We want them to think in terms of DevOps and automations. Stop going to this to configure VLANs. So you can still go to the GUI. You can actually SSH to our switches if you want and do standard switch commands on them, but we want it to be all automated. So think of control as transparent. So we try and push, if we can, our data up to what you might call a more single pane of glass or something that the IT operator would look at. vCenter is probably one of those tools. I know there's higher level tools than vCenter even. Whatever their interface is, whether it's their portal, vCenter. So in this case, we've built a plugin into vCenter. And if I go up to the top, I'll just touch about this very, very quickly. So we built a vCenter thing, and of course it's not there, is it? That's interesting because I didn't enable it. So if you go to vSphere and you got to say, I won't wait for you to do it. Basically, you've got to register the plugin. So basically registering. Adds a plugin, and then we put some of our data is in vCenter. Our phase 2, which will come later, is going to massively enhance it. We want the IT operator to know, when the IT operator, he knows his ESX host. If the ESX host can't talk, in that example, he has no idea why it can't talk, right? We obviously do know why it can't talk. We could provide that data exactly to them in that vSphere plugin in vSphere. So there's a lot of conditions you can create where you can cause a network problem and you don't know why from an IT perspective. And sure, you can call the network guy and he can spend a couple of hours troubleshooting. What if you've got that data to hand right now? That's really where we want to go from that visualization point of view. So we'll see more of that. These visualizations, particularly Kevin's demo, has got a very powerful integration into Ambari that we're going to show, again, showing the direction for us. We go to a lot of network operations centers, and they've always got 25 screens up because they've got 25 products they're monitoring. You've got to bring it all together to make sense of it. So that's it for the vSphere stuff. Let's talk about switch tax a little bit and talk about Nutanix, if we don't mind. So why is Nutanix interesting? Nutanix, the basic level, obviously, is relatively similar to vCenter. It provides you with a tool that you can create VMs.
I'd hate you to say that. And Nutanix would hate you to.
But yes, let's face it. If when I log into the Prism interface, if I can remember the password, if I can type the password, stop fat fingering it. I'll log into this one. Let's face it, this is a Nutanix for Acropolis, and this one is a Nutanix for ESX. Obviously, ESX runs on Nutanix as well. They've got both options. I've used this product a lot. Actually, really a big fan of this Prism interface for Nutanix. Really powerful product. So the reason why I say it's, from my perspective, it's similar, because obviously it's a tool that gives you the ability to create virtual machines, virtual environments, which from a Plexxi Connect perspective is similar. So we've built a little. So the vCenter stuff that we've shipped us, that's live on this network. The Nutanix stuff I'm showing you is one of our development networks, so I'm not going to break it like I did with the vCenter stuff, if you don't mind. But I'm going to show you a little bit of what we've done. So the base level for, not this one, this guy, this is where I have the Nutanix sitting. But at base level, we've done some of the same stuff. So if I go to my network view, for Nutanix, I've now created, I've harvested the Nutanix data. It's a base level. So I've got Nutanix controller VMs, I've got Nutanix regular VMs, both in Acropolis environments and ESX environments. So whatever the hypervisor, we can build that. So you can start to do the same things that I showed in the ESX environment. If I do a migration in the Nutanix environment, Nutanix is a nice task-based, event-based feed through their APIs, so you can get all the events and tasks when you do a migration and all of that kind of stuff. So in that bit, it's kind of similar to the vCenter from this demo's perspective, so I'm not going to go into too much detail with that for time purposes. The bit that is interesting in this vCenter, in the Nutanix environment, is what I term the hyperconverged storage. So in that vCenter environment, I didn't use any shared storage at all, I just used the local storage. vCenter, obviously, VMware has a similar kind of product, but we're going to talk about Nutanix now. So obviously, Nutanix takes all the SSD fixed disk data and gives you a big pool. In fact, if I jump to my Nutanix dashboard, this one doesn't have much because this one's got 11 terabytes. It's a big pool of 11 terabytes that it's made available. So if I go to ESX in this environment, I'll see this massive data store, 11 terabytes. And obviously, then the replication data storage for that volume basically is handled by the Nutanix software. It replicates it, manages it, and keeps it all alive. It's very cool things that you've got a VM running on a host, you can unplug or you can disconnect the port that it's connected to, and that VM appears over here. Cold boots to run it because it's got copies of it all over the place. So it's a really powerful, great solution. Why do we care about it from Plexxi perspective? Because, well, guess what? All this networking storage traffic generates a little bit of network traffic, to say the least. Every time you create a virtual machine, disk operation, there's potential pieces of data going around your network. Now, in a shared type environment, it can interfere with your application traffic, or the application traffic can congest the paths it's on. It's a potential problem for a large environment congested network. So what does Plexxi do about it? Multi-purpose networks. Let's build something dynamic for the Nutanix storage data. That was our first thought. So when we started down the Nutanix route, the first thing we did is we need to learn about Nutanix. We got the equipment, we put it in-house, we started looking at the packets with a lot of data, and actually we built a little dashboard that we're going to also ship with the Nutanix. Actually a little Cabana dashboard that tells me all about Nutanix. So I built this little guy, or we did, I didn't build it. Basically it tells me this is what's going on with my Nutanix environment. There's actually a lot of traffic passing between, it's the IP addresses, we should have got their node names in there. Basically it's showing me here's the profile of who's talking to who. The red ones are obviously sending a lot of data. It's got a little source desk donut configuration. And this one's probably the most interesting one to us. It's got all the TCP ports that it uses to talk between the controller virtualization manager. Tons of them. Actually, there's Nutanix, they have a page of all their TCP ports. Actually, I'll take that back. They have 3 pages of TCP ports that are used in that environment. A lot of TCP ports, a lot of different ones. We've identified the key ones. So we looked at this in terms of how do we do an overlay for Nutanix. Now I can take every single TCP port combination I've got. Stargate is the biggest one because that's the I/O transfer. I could take every TCP port. What we decided in the Nutanix case is we just take all the controller virtualization manager data, CVM it's called. You'll hear me say that out. Take all the CVM data and build a little network for the CVM. So just for that traffic. And we'll use that same logic we use for the VMotion. Isolate that traffic. we could go into this one, Cassandra traffic. That's the metadata store. We could prioritize Cassandra over Stargate. We haven't done that yet. Kevin was demo. He'll show that actually we've done exactly that for Hortonworks and done different things but based on different protocols. So our product has the ability to go very fine-grained traffic engineering. This case, we've decided we're just going to build the basic fabric for Nutanix so you can see it. And we built a little affinity rule similar to what we did. I'll go to my affinities on this guy. You see it's harvested the Nutanix CVMs. And the Nutanix CVMs, all the traffic's coming from these guys. Built the same kind of thing. It's just a little CVM model, and there's a rule here that says, actually a little bit more detail on this one. This one has an average and burst ratio. So there could be a lot of these CVMs. So our logic in this base thing is I don't want to consume my entire fabric with CVM traffic. So their burst and average ratio allows us to keep it dedicated to a single 10 gig fabric for this example. If you wanted to expand it, you can expand it more. So that got us into the world of thinking about how do we want to visualize this? Because we're basically, I hate to use the term overlay, but our visualizations are a kind of an overlay. It's not there's no overlay technology built into this. It's basically dedicating paths or sharing physical infrastructure paths. But we still want to show when we build a logical topology for Nutanix, we want to actually show it in a nice graphical representation. You can see what it is. So that's where Eric, a few months back, we were talking about how to do this, and Eric came up with some more advanced visualizations to be able to see at a glance what are my different topologies look like, how much of the fabric they're using, and get down to those details. So much